Hi, my name is Stolen ID and welcome back to the last part of our Lua tutorial. And this time we will talk about loops, and that's pretty awesome stuff because it allows you to do checks on many things, on many expressions you can do. You can check for values, you can check for variables, and I don't know what. So yeah, let's just get started and head over to the file here. We have that I have set up for you, and I will go over it line by line as we did it last time, and I hope you understand everything. I tried to simplify things, but I have to go a bit more technical this time. Um, but yeah, we will see. So the first line we have here is t insert equals g table insert, and what this basically does is it assigns a global value that is inside of Lua to tinsert, t-insert. So we have our table function, which is given by the Lua interpreter, and we can use it with tinsert keyword. In the bot files, like this is done in the header, so on the top of the file, and in Scalebot, this line will be already included in some way. So if you use Scalebot, you don't have to do this, so don't worry too much about it. And yeah, okay, so we have our variables again here. You already know most of them. I mean, just booleans, a number and a name, a string. And let's head on to the first kind of loop. This is a conditional loop. It's an if loop, and the if loop allows us to ask for certain expressions. So what we can do is we ask for, in this line we ask for, is be alive, the boolean be alive, is it true? If it's true, then we're gonna execute the code that is in the body here until the end is reached. And we could of course do multiple lines of code here, so yeah, this allows us to execute code in certain cases. The next thing is we can ask if the condition is not met. So to do that, we have to use this sign here, and this would basically ask, is this boolean, which is true, not true? And both of those examples are extremely bad programming behavior. Don't do that. I will correct those statements for you, and you shouldn't use it anywhere, in any other way. So to ask if a boolean variable is true, you just write its name. So this means exactly the same as we had before. It just asks if be alive, then set be alive to false. And if be alive, as be alive is a boolean, it just looks for its value, which is true in this case, and will set it to false. So this is the easy way to do this. And we're also gonna delete this. Theoretically, I could do false, but so I would compare it. Is false the same value as be alive has? This is basically what happens here, and this is also a very unfine programming behavior. You should write instead if not be alive. So basically the not inverts the result of our expression in here, and returns the opposite, basically. Yeah, that's it. So instead of true we would have false, and instead of false we would have a true. And only if it's true we will execute this code. So the next thing, we have numbers, and as you can see we have unhealth defined with the value of 20, and we ask if is unhealth smaller than 15. If yes, then we will set be alive to false. So this code might not make any sense to you, and it's pretty stupid. But this is a simple comparator. Is the number smaller? We could also do is the number equal. If you want to ask for something, if something is equal, you have to do two equal signs, not one. One equal sign will give you an error from the interpreter. You could also ask for bigger, and you could ask if is it greater or equal 15, or in that matter you could also ask is it smaller or equal than to 15. So whenever this condition is true, it will execute the body. So this is not that complicated, I guess. So we could do the same thing for strings. So we have our name here, which is hero, and we ask, does name equal enemy? This is not the case, so it wouldn't actually execute. But we have an or here, and this bracket with another two expressions in it. So let's just go over this. What exactly happens when we reach this line? As first, it will compare as name to this given fixed string enemy, and it will see, oh wait, it's not true. Then it comes to the or and says, okay, here's a bracket. So the bracket counts as one expression for this or. So if this complete bracket returns a true, we would execute the body anyway, because either the name has to be enemy or the brackets has to be true. So the bracket is only true if be alive is true and health is greater than 50. So those conditions have to be true. If one of them is false, the bracket will be false. This is because we have an and here. You could of course use an or here or an and here, and we could change the brackets maybe, but that's not needed. So yeah, I think this is quite understandable. If not, let me know. I can always do another video, you know. Let me just check. Oh yeah, we have to do else. And we can do an else here. And write some other code here. What would be used? False. Be used is a boolean, so we set it to false. And what happens now is it checks if either as name is enemy or those two conditions are true. If neither of these is the case, the whole thing is false and it will not execute this body. However, we have an else option here. So if this is false on top, it will execute instead of this body, it will execute this body and set be used to false. So we can do multiple, we can ask for the opposite basically with an else. Note you don't have to do other than, and you don't have to do another and. You can just write the else here. Everything else will return you an error. And let's just expand on this. We can make an else if. An else if, as you might think already have, as you might imagine already, allows you to check for another condition instead. So as name should be nil. Be aware here we need a then again because we ask for something, and nil basically means the variable has no value assigned to it. So for what reason, however, it might be nil, and if that's the case, it will execute this body, but only if this condition's already false. So first it will try to first it will check to this line if it's true. If it's not, it will check if sname is nil. If it is nil, we execute this body. If it's not, we just end the if and nothing happens. So we can extend this as long as we want. We could do another else if, let's say, sname equals, I don't know, Amun-Ra, then sname should be Phoenix, and in the end we just do other else, and we do how, I don't know, be alive true, and so it will check this line first, then it will check for this line. If this isn't true, if this is true, only this will be executed. I have said that before, I think. So it will check this one after the first one. If this is also not the case, it will ask for this one. And if this is also not the case, it will always execute this one. So yes, we can differ our code by far with a simple, with a very simple comment structure like this. This allows a great flexibility in your code, and you will find yourself using if, else, and then, and all this stuff pretty often. This is basically what is programming about. Yeah, I think I covered the most. I covered everything, I think, for else and for if, and yeah. So let's go on. For loops. Yeah, the for loops are a pretty neat thing. They are basically irritated and iterator. Excuse me, it's an iterator. And what iterator is, it cycles through its a counter value, and be aware it does not have to be named counter. I just decided to call it counter. So let's go over this code one by one. Here we have the for expression, and the first thing you do is, after the for, you write a name for a variable. In the best case, you make a new variable here, which in my case is called counter, and you assign a value to it. And I assigned 0, so then you make a commenter, and then I have written 6. So what this will do is, it will run the code here, the body, everything between do and end will be run. It will be run once, while the counter will have the value the counter is on right now. Then the for loop will increase the counter by 1, check if the counter is on 6 already. It's not, it's on 1, so it will run this again, printing a 1 here instead of a 0 as before, and it will run it 4 more times until the counter has the value 6. So we could also use, instead of those two numbers here, we could also use variables like, I don't know, and health. And yeah, maybe we should just, I would just write this. So yeah, now the counter, the for loop, will run until it has hit the value of unhealth. And unhealth is defined as 20, so it will run 20 times. You might need it someday, we don't know. But for now, let's just return this to 6. And there's a third argument you can give to a for loop, and this has also to be a number. And if you think about it, you might have guessed it already. This says the for loop, this tells the for loop by how much it has to increase each cycle. So in standard cases it uses 1, but if you define 2 here or 3, it will actually increase the counter value by 3 each time. So it will print counter is at 0, increase it by 3, counter is at 3, we'll increase it to 6. Oh, it's 6. Okay, we're fine. And that's it. Yeah, anything else at this point? No, I don't think so. So let's go on with the I-pairs for loop. The for loop has the ability to cycle through tables. So I have defined this table here called t-number, and t-number has multiple numbers inside of it, and as we learned in the previous tutorial, those numbers will have keys assigned to them, which are 1, 2, 3, 4, 5, and 6. And what this does now is you write any name here for any 2 variable names you want to use. That's a completely free choice. And I used K and V for this, which stands for key and variable. And oh, sorry, and for value. Not my day today. And what this for loop will do, it will assign those 2 variables each time it runs the code to the corresponding table entries. So I-pairs checks for the first key in t-number, with for 1, assign 1 to key, and will assign the value of the 1, which is 2, to value. So this line would actually print value. Let's do it on the scripted. Value is value, which is in this case 2. It will run again, assign the key to 2 to the key. For fuck's sake. And the value will then be 5. It will print value is 5. Then it will print value is 9. Then it will print value is 2, and so on. You could of course also print the key value here. So yeah, you might need that. For some reason it's actually possible that you need the key numbers. And the great thing here is that I-pairs runs through the table in order, so it runs from 1 to how long your table is. Yeah, this is pretty useful. So you have a guaranteed order of your table. Was that everything? I think this was everything. So the next thing, I have created a table called tstrings. As we learned before in the previous video, we can assign table elements in different ways, and we would have here assigned to key number 1, we would have the string no. Key number 2 will have the value assigned yes. Then we t-insert into the table strings the string maybe. And what t-insert does, it's basically a function. We defined it on the beginning, as you might remember. What this does is it actually adds the value I give it to the end of the table. So this will automatically get the key number 3. So we have 3 elements right now, 1, 2, 3, with the values no, yes, and maybe. And now we're gonna add elements with a custom key name, which is hello in this case. So my hello key will be hi there. It will have the value hi there assigned to it. The key bye will have bye assigned to it, and secret will have don't tell anyone assigned to it. And all those 6 elements are now part of the same table, But we have a problem here. This is where I get a bit more technical here. The problem is, if the keys are assigned automatically, we speak of an array pod, so it's numbered straight through. And there's a technical difference in the background happening in the interpreter. And our array pod now looks like this. 1 is no, 2 is yes, 3 is maybe. But we have custom keys, and they are not numbered or anything. So the non-array pod will be hello, hi there, bye is bye, secret is the Italian one. And the big difference and big problem we might get here is if we use I pairs on T strings. Because I pairs actually means indexed pairs, and I pairs will only run through those three values, those three variables. It will not run through those three. And this might be a problem if you're not aware of it. So to run through a table, through all elements of this table, you may not use I pairs, you have to use pairs without the I in front of it. The problem for pairs is that pairs actually won't guarantee that the order of the table will be fixed. So if you change your table on runtime, for example, it's very likely that the table contents get mixed up, and it might print this don't tell anyone before it prints hi there. So this could make a problem. And if you have to use the table in a specific order, you might just code it in a way that you can use I pairs. So you might code it in a way that you always t-insert or always define it on the beginning if it won't change. So yeah, just be aware of that. Well, the next topic, I have another if loop here. And I did this to show you a bit more about this array pod stuff. I ask here if my table t number, which we have used here, is greater or equal to 6. And we have 6 elements here, so this should be true, because if you use this number sign in front of a table name, it asks if the array pod has it asks for the length of the array pod. So basically this has 6 automatically assigned number keys to it, and it will have a length of 6, so it's fine. It will print, will execute the print command, and the print command does another neat thing. It asks for the length of T strings. So you might think, hey, if it works on T number, it might work on T strings, and that's not the case entirely, because the number sign in front of a table name only asks for the length of the array pod, as I said before. So this won't print the number 6 as you might expect it, because we have 1, 2, 3, 4, 5, 6 elements. No, it will print only 3. It will print the number 3 because we have only 3 array pod members, as we can see here. So this will be true because T number has only array pods, and there are 6 of them, and it will print 3 because there are only 3 array pod members in T strings. Complicated. You know what? We're just gonna run this code so you can actually see that I'm not kidding you. Where do I have? I have to go up to T number, I guess. Here's the browser. You know this demo page from the last video, I guess. If not, there's a link in the description, go for it. So I pasted my code here, and I'll run it. Oh, your program failed. Oh, of course my program failed to run. I used t-insert, and it's not defined in the web page yet. So let's just add it on top here. Run. Now it worked. So let me just align this here real quick. So the first part is value is, and as we said before, this is cycling in order through the table. 259202, 259202. So this worked. And then we use the pairs command next instead of the I pairs. As you can see, it prints all the string members. And then we have the 3 as I predicted. So this expression actually it has been true. And it printed the arrow part length, which is 3, not 6. So yeah. Anything else? No, I think we are fine. So the next thing are while and repeat loops. The last tiny bit to completion. So yeah. What are while loops? While loops are pretty, and I've defined a number variable here, which is called I with the value 4. And what while does, it checks for this condition, for this expression, and says while I is greater to, I will do this body, which basically means it will run this body as long as I isn't greater as 2 anymore. So this can lead to multiple problems. First problem, if you don't change I at all, if you don't change this number but ask for I to be greater than 2, this while loop will run forever. It will never ever stop. This is a problem, because if the I doesn't change, it can't be lower than 2. Next thing, if I increase the I in the while loop, it will have the same problem. But I have this line here, this if line, and this if line basically asks, if I is greater than 6, then break the while loop. This is a break command. And this just ends the if question. So we will run until I is lower than 2, is 2 or lower, or if it's greater than 6. If one of those 2 cases is true, the while will stop and continue with the rest of the code. But there is the hoax. Don't code this like that. This is bad programming, if you ask me. Because if you just want to ask if you just want the while loop to run until it's greater than 6, and you might not need this minimum condition. So if you say it can run whenever it wants, but it may not be bigger than 6, just get rid of this line. I will comment it out and say if I is smaller than 6. So this code will now run twice, because we have I on the defined as 4. It will check the expression, print this string, increase it by 1, print the string again, and see, oh, I reached 6 again. I reached 6, wow. Excuse me. I reached 6 already. Let's not execute anything else, and it will go on with the rest of the code. So a while condition, by the way, the while condition won't run if its expression is not true. So if I define I as 7, the while loop will never ever run, because I is not smaller and not lesser than 6. Another thing, if you have, for some reason, if you insist on using a break in your while loop, don't use it in the beginning. Rumors has it that you shall not use a break anywhere else than in the end of a while loop, because the interpreter might be confused by it. So I would just delete this and leave you with the knowledge that a while loop can be, in most cases, be replaced with a for loop and be much easier to read, in my opinion at least. If you ask me, don't use while loops, use for loops. For loops are just nicer to you. I don't know. Yeah, let's change it back to 4 and head on to the last thing in this tutorial, the repeat loop. The repeat loop has one neat thing you have to know. The repeat loop will run at least once. So runs at least once. Yeah, and this is actually the case. Repeat loop runs like the while loop until the condition is met, but it checks for the condition after it executes the code, which basically means the exact same thing as I said before. It runs the text, checks is I equal to 0. If it's not, repeat the process. If I wouldn't have this line, of course the repeat loop will run forever. So be aware to code this a proper way, as you will see your program stuck. So yeah, this will basically decrease I every time and print the string text every time until it meets this condition. Be aware, if you write false here, for example, or you use a variable here that is not defined, a variable that's nil, it will run forever. So make sure that the variables you use are actually existing here. Yeah, you could also mimic the behavior of a repeat within for. So you can use a for basically everything. I didn't mention that before. Oh my god. A little extra thing to for loops. If I find them, where are my for? There are my for loops. These counters, these step counters, increase at the moment. It increases, each cycle increases by 3. You could actually make a minus, so you could count backwards and decrease the value. So if we do a 6, 0 minus 3, it will start at 6, print counters at 6, decrease it by 3, print counters at 3, decrease it again, counters at 0, and we are done. So yeah, I would say we just run this whole file now, check if everything is working. You can do this for yourself. I will link the file in the description or in the forum thread if you are watching this from the forum. Yeah, it runs successfully, and this is, like I said before, count is at 6, decrease it by 3, as at 3 is decrease it by 3 is at 1. Then we here. Hey, it's just gonna print something. It starts at 4, so you can see it runs 2 times, prints 2 times until because the 4 is then 6 and will not be lower than 6, and therefore it won't run again. And our repeat runs 1, 2, 3, 4, 5, 6 times as expected, because we now have I defined as 6. The value is 6, and this will only stop once I is 0. If you are a bit superstitious, you might also do lower or equals 0. Doesn't really matter. But if you decrease by 2 each cycle, this might actually be necessary, because you could jump over 0, so you could have a value of 1. Let's just do this. Plus 1. So if I is 1 and it gets decreased by 2, it won't be 0, but it would be lesser than 0. So you might need this in some cases. Yeah. As I said, most stuff is in the description and in the forum thread, and I hope you liked the tutorial series so far. If you have any questions, let me know. Write comments in the forum or here on YouTube, and yeah, whenever you have a problem, I might do another video answering the most common questions, or maybe there will be other video tutorials about more advanced stuff in Lua, like prototyping or something like that. But with this knowledge I gave you so far, you should be able to code pretty much the most things in HON bots or in HON modding you want to. So yeah, thanks for watching. I hope you liked it, and we will see us soon. I hope. Or not.